Section 1, Introduction. The Husky is a powerful ultra-high pressure pump developed and manufactured by Flow International Corporation, the world leader in UHP water jet technology. The Husky is designed for minimum maintenance and reliable performance at full-scale industrial use and is available in either diesel or electric models. In this video, an electric model is used for the demonstration, but differences between the electric and diesel models will be pointed out. In the next several minutes, you will become acquainted with periodic maintenance and troubleshooting procedures for the Husky. Use this video as a supplement to your operation and service manual and hands-on training from your supervisor and Flow International Corporation. Section 2, Operation and Periodic Maintenance. Getting the maximum life, safety, and efficiency from your Husky pump will depend on daily inspections and periodic maintenance. Periodic maintenance can be regularly scheduled preventive maintenance, and it also includes replacing worn parts that have reached the end of their service life. By implementing regular, effective periodic maintenance, you will minimize unscheduled downtime, maximize equipment utilization, and eliminate unsafe operations. Here are some tips to get you started. Maintenance tips. Stock enough spare parts to minimize downtime. Keep your work area clean. Keep a complete set of service tools with the Husky. You can also take some general precautions to ensure maximum performance from your Husky and its spare parts. Maintenance precautions. Use only Flow replacement parts and follow Flow's recommendations for periodic maintenance scheduling. Use only high-pressure fittings, valves, and tubing certified for 60,000 psi. Immediately repair any leaks in the fittings or connections. Do not over-torque fittings to stop leakage. Follow the tubing manufacturer's recommendations for high-pressure tubing bending radiuses. Clear all personnel from the area when you pressurize any new, rebuilt, or serviced high-pressure component for the first 3 minutes of operation. Make sure high-pressure water is bled down before servicing any part of the system. Tools. Using the right tools makes any job easier and more effective. Here are some guidelines for using tools on your Husky pump. Use only approved test equipment and check it regularly for proper operation and calibration. Use the proper tools for the job. Otherwise, you may damage your equipment or injure yourself. Clear all tools and rags from around the machine after servicing and before starting the pump. Treat the Husky and ultra-high pressure cleaning tools as you would any other high-speed cutting tool. Although the water jet may appear harmless, it is a high-energy tool. Careless operation can be extremely hazardous, but if you follow simple precautions, the Husky will perform both efficiently and safely. Safety. Never start the system unless you know how to stop it. Do not allow the water jet stream to touch any part of your body. It will cause serious injury. When servicing the equipment, shut it down and mark it with a warning sign. Wear appropriate clothing and safety gear. Always consult your operator's manual for complete safety guidelines and practices. Section 3. Troubleshooting and service procedures. Your operation and service manual contains step-by-step instructions and illustrations that explain how to service the Husky. Here are some general service tips. Service tips. Inspect the system every day before operating it. If you see any malfunction, correct the problem. Read and thoroughly understand each service procedure before starting the work. If you have questions about any of the procedures, contact Flow's Technical Service Department. Turn off electrical power and relieve the system pressure before starting any service. Handle critical parts with care and avoid scratching or denting ultra-high pressure system components. Make sure all operating parts of the machine are clean. Inspect all around the equipment for parts, tools, and rags. Remove them before operating the equipment. Maintain a service log. It will provide important information to help you stock spare parts and diagnose problems. Check valve service. Replace or service the check valve after a specific number of hours, following a specific length of time, or if it fails. There are two indications a check valve has failed: a loss of operating pressure and elevated temperature at the end cap. This increase in temperature is first noticeable on the underside of the end cap, near the accumulator. To replace or service a check valve, first shut down the system. Make sure the pressure is bled down. Lock out the controls. Close the water inlet valve. Disconnect the low-pressure hoses from the manifold. Disconnect the high-pressure tubing from the manifold. Remove the pressure control valve from the manifold. Remove the 6 bolts that attach the manifold to the end caps. To avoid damaging the O-rings and backup rings that create a seal between the end caps and manifold, lift the manifold straight up. Do not slide the manifold on top of the end caps. Next, remove the 12 tie rod nuts. Now, using 2 screwdrivers or pry bars, pry the end caps from the high-pressure cylinders. Place the end cap on a workbench. Then, place 2 small screwdrivers in the groove on the check valve body and pry the check valves from the end caps. Remove the O-ring from the outside of the check valve body and secure the check valve in the special check valve clamp. Now place the clamp in a vise or hold the clamp by some other means. Remove the inlet poppet and the inlet seat assembly. If the check valve has failed, look for erosion, pitting, or other signs of wear between the poppet face and seat face, and between the seat and body. When you replace the inlet poppet and seat assembly, also replace the inlet screw. Rotate the check valve so the outlet cage is exposed and remove the cage. Remove the outlet poppet assembly and outlet seat. Check these parts for erosion or other damage and replace them if necessary. Using a small snap ring pliers, remove the retaining ring. Also remove the O-ring, high-pressure seal, and brass-colored backup ring. Remove the check valve body from the clamp and examine it for damage or wear. Clean the check valve body using solvent and compressed air. If the check valve has failed prematurely, replace only the damaged parts. If you're servicing the check valve at a regular interval, replace all the components in the check valve rebuild kit. For reassembly, secure the check valve in the special check valve clamp. Replace the brass-colored backup ring, green-colored high-pressure seal, O-ring, and retaining ring. Install the outlet poppet seat, poppet, and spring. Apply blue lube to the threads of the cage and put the cage back in place. Torque the cage to 60 foot-pounds. Rotate the check valve so the inlet end is exposed. Use blue removable Loctite number 242 on the inlet screw. Install the inlet poppet and inlet seat assembly. Use a pencil to mark the outside of the check valve body and the outside of the inlet seat to assure, after torquing, that the inlet holes in the body are properly aligned with the inlet holes in the seat. Torque the inlet screw to 120 inch-pounds. Do not use a foot-pound torque wrench to torque the inlet screw, or you might damage the inlet screw. Remove the check valve from the check valve clamp. lubricate, and install the O-ring on the outside of the check valve body. Using a high-pressure cylinder and the rebuilt check valve, make sure the check valve and high-pressure cylinder have the correct gap, as described in your operation and service manual. Remove the O-rings and high-pressure seal from the end cap. Clean the end caps with solvent and compressed air. Reinstall the check valves in the end caps as well as the O-rings and high-pressure seals, or replace if necessary. Install the end caps onto the tie rods. Apply silver anti-seize to the tie rod threads. Also use the anti-seize on both sides of the flat washers. Hand tighten the tie rod nuts onto the tie rods, making sure the threaded holes for the manifold are aligned. Apply white food-grade lube over the O-rings and backup rings. Place the manifold onto the end caps. To prevent damaging the O-rings and backup rings, avoid sliding the manifold on the end cap surfaces. Apply silver anti-seize to the threads of the 6 manifold bolts. Also apply silver anti-seize to both sides of the washers. Torque the bolts to 10 foot-pounds. Torque the end cap hex nuts evenly in a diagonal pattern in 3 steps. First, to 100 foot-pounds. Then 175. And finally to 250 foot-pounds. Now, using a diagonal pattern, torque the manifold bolts. First to 50 foot-pounds, then to 100 foot-pounds. Replace the pressure control valve, high-pressure tubing, and low-pressure water lines. To restart the machine, follow the Husky pump startup procedures in your operation and service manual. Dynamic seal and plunger service. There are several indications that the dynamic seal needs servicing. Elevated temperature at the backup ring housing. A pulsating cooling water drain hose. An increase in cooling water temperature. Hot water leaking from the drain holes in the crankcase. To service the dynamic seals, follow the check valve service procedure to remove the end caps. Then, slide the high-pressure cylinder off the plunger, being careful not to lose the spring, plunger cap, and filler tube that are located inside the cylinder. Inspect the cylinder and its small parts for cracks and erosion. Replace any damaged parts. Slide the backup ring housing off the plunger. Use the seal installation removal tool to remove the backup ring, dynamic seal, lip seal, and U-cup spacer from the backup ring housing. Clean the backup ring housing with solvent and compressed air. Be sure to inspect the cooling water ports for obstructions. Remove any obstructions that are found. When a dynamic seal is replaced, the backup ring and lip seal must also be replaced. Use the seal installation removal tool to install the backup ring. Place the backup ring on the tool with the slots facing up. Lubricate the backup ring with white food-grade O-ring lubricant. Install the backup ring into the backup ring housing. The slots in the backup ring will face down toward the bottom of the backup ring housing. The backup ring should fit tightly into the backup ring housing, but it shouldn't be a press fit. Use only hand pressure to install the backup ring. If the backup ring fits loosely in the backup ring housing, replace the backup ring housing. Lubricate the seals with food-grade O-ring lubricant. Use the opposite end of the tool to install the dynamic seal and the lip seal. Place the dynamic seal inside the installation removal tool and install the lip seal over the dynamic seal with the lip facing toward the tool. Using the tool, install the dynamic seal and lip seal into the backup ring housing. The lip on the lip seal should be facing up when it's installed in the backup ring housing. Remove the tool and press down on the dynamic seal to be sure it's seated against the backup ring. Install the U-cup spacer slots up over the dynamic seal. Whenever the dynamic seals are being replaced, the plunger and guide bearings must be inspected for wear or damage. Slide the bearing carrier off the plunger. Remove the snap ring that retains the forward guide bearing. Remove and inspect both guide bearings. Replace the guide bearings if you see evidence of chipping on the inside diameter. Slide the guide bearings onto the plunger, and if there is excess play, replace the guide bearings. Another sign that the bearings are worn is if the backup ring shows signs of plunger rubbing. Thoroughly clean the bearing carrier. Install the guide bearings with the metal covered end toward the high pressure cylinder. Install the snap ring. Inspect the plunger for scratches or cracks and replace it if necessary. To replace the plunger, first remove the drain hose on the left side of the subplate. Then use a hex head drive tool to remove the 8 bolts that hold the subplate in place. Slide the subplate off the pump and be careful not to scratch or damage the plungers. Next, thread 2 bolts into the 5/16 18 threaded holes in the seal carrier. Pull on the bolts to remove the seal carrier. Remove the plunger nut using a crow's foot wrench, using care so you don't scratch or nick the plunger. Remove the plunger nut and spring from the pump. Remove the nut and spring from the plunger. Clean the plunger nuts with solvent and compressed air. Check the threads for nicks or tears. Wipe the plungers clean with a rag and replace them if necessary. Apply blue lube to the threads of the nut. Place the spring and plunger nut over the plunger and install the plunger nut into the pony rod adapter. Torque the plunger nut to 70 foot-pounds. Install the seal carrier, being sure to lubricate the O-ring and seals with white food-grade O-ring lubricant. slide the subplate onto the pump, being careful not to damage the plungers. Torque the lubricated subplate bolts to 125 foot-pounds. Install the bearing carrier and the backup ring housing. Stand the high-pressure cylinder on a level work surface and install the check valve. Make sure there is a 10 to 15 thousandths gap between the check valve body and the high-pressure cylinder. If the gap is not correct, replace the cylinder and/or the static seal on the check valve. Lubricate the cylinder O-rings with white food-grade O-ring lubricant and install the high-pressure cylinders onto the pump. Reinstall the end caps according to the check valve rebuild procedure. Cooling bearing seal and oil seal replacement. If water has been leaking from the drain holes in the crankcase, you will need to replace the cooling water bearing seals, which are located in the subplate. To replace the cooling bearing seals, follow the directions in the check valve and dynamic seal service procedures section in the operation and service manual. Remove the end cap, high pressure cylinder, backup ring guide, seal carrier, and subplate. Remove the seals using the seal removal tool. Lubricate the new seals with white food-grade lubricant and install them using the opposite end of the seal tool. If oil has been leaking from the drain holes in the crankcase, you will need to replace one or more of the seals that retain the oil in the crankcase and/or the pony rod adapters. To inspect the seals, follow the directions in the operation and service manual for check valve and dynamic seal service procedures. Also, remove the plungers and seal carriers according to the dynamic seal and plunger service procedure. Inspect the oil seals on the seal carrier. If any one of the lip seals shows signs of leakage, replace all 3 lip seals. Replace the O-rings as needed. Next, using the 2-part pony rod adapter tool, remove the pony rod adapter. Thread part A into the pony rod adapter, and then slide part B over part A so the tabs on the tool align with the notches on the pony rod adapter. Thread a nut onto the stem of part A. Use a 1 3/8 socket to remove the pony rod adapter. Remove the pony rod and O-ring from the inside of the pony rod adapter. Clean the pony rod adapter with solvent and compressed air. Inspect the pony rod adapter. If there are any scratches, replace it. Inspect the pony rod. If there are any burrs on the ends of the pony rod, replace it. If the O-ring appears flat, is damaged in any other way, or if the end of the plunger that contacts the pony rod is wet with oil, replace the O-ring. Lubricate the O-rings with white food-grade lubricant before installing them into the pony rod adapter. Push the pony rod into the pony rod adapter. Now apply removable blue Loctite number 242 onto the external threads of the pony rod adapter. Check the alignment of the counter bore in the wrist pin. The pony rod must fit into this counter bore. Using the pony rod installation tool, reinstall the pony rod adapter. Torque the adapter to 75 foot-pounds. Follow the dynamic seal and plunger service procedure to reassemble the pump. A good practice is to rotate the crank by hand anytime you've serviced the plungers or pony rods. This will confirm there is no binding within the pump before you apply power. External compensation valve. Pressure output of the pump is controlled by the external compensation valve. A loss of pressure is an indication the valve may need servicing. However, remember that a loss of pressure could also be caused by bad orifices or failed components inside the high-pressure pump. The output flow across the external compensation valve should be constant for a given pump RPM and orifice size. If you're experiencing a decrease in pressure and an increase in the output flow from the external compensation valve, replace the poppet and seat in the external compensation valve. To replace the poppet and seat, first remove the hydraulic pressure hose and the water drain hose from the external compensation valve. Next, unscrew the valve from the high-pressure manifold. Set the valve on a workbench. Remove the poppet and seat. Remove the seal from the poppet seat. Replace the seal only if there is evidence of cracking or erosion. Now remove the body from the actuator. Inspect the plunger assembly. If there are erosion marks on the plunger assembly, replace it. To remove the plunger assembly, first remove the retaining ring. Then pull on the plunger assembly. Both the cap and the piston will come out of the valve. Now push on the oil connector to remove the separator plate and the oil connector. Inspect the seals on the piston and separator plate. Replace if needed. Inspect the breathers. They must be free of clogs. Replace the rod seal. An indication of rod seal failure is water leaking from the actuator breather. Use blue lube on the actuator threads and use food-grade O-ring lubricant on all seals and O-rings. Reassemble. Torque to 150 foot-pounds. Changing inlet water filters. The inlet water filters must be changed before the difference between the pre-filter and after-filter gauges exceeds 60 psi. To change the filters, first shut off the incoming water, then open the vent on top of the filter housing. For diesel pumps only, drain the filter housing by opening the ball valve on the bottom of the filter housing. Remove the clamp. Remove the filter top. Unscrew the filter hold-down handle. Remove the hold-down plate and the 4 filters. clean out the filter housing. Install the new filters. Install the filter plate and thread the handle into position. To prevent unfiltered water from flowing past the filters, be sure the filter plate is pressed firmly and evenly against all the filters. Replace the top and close the vent. Open the inlet water valve. Now, to vent the air from the filter housing, reopen the vent until a solid stream of water is noted. Restart the Husky pump using the startup procedure. Lubricating the electric motor. First, shut down the system. Then remove the grease relief plug from the front and rear bearing housing. Next, using a hand-operated grease gun, lubricate the bearing until fresh grease appears at the relief plug opening. Use only the following lithium-based lubricants, unless the motor company nameplate specifies a special lubricant. Shell Alvania No. 2, Chevron SRI No. 2, Exxon Beacon 325, Mobil Mobilux No. 2. Operate the pump at the lowest pressure setting for 7 to 10 minutes with the grease relief plugs removed. If you must place the pump back into routine operation immediately, it's okay to operate the pump for 3 minutes only. Additionally, lubricate the idler pulley weekly. Replacing water-absorbing filter and particle filter elements. There are two filters in the hydraulic lubrication system, a particle filter and a water-absorbing filter. Both filters have a change indicator that will pop up and display red when the elements require changing. As part of your regular maintenance, check the indicator every day. At startup, the indicators could falsely indicate a need to change the elements. To reset the indicators, push the indicator button down. If at any time the indicators pop up when the pump is at normal operating temperature, change the filter elements. First, remove the filters with a strap wrench. Then wipe the filter head and O-rings. Install the new filters, tightening them with a strap wrench. Failure to change the elements will cause damage to the internal components of the lubrication system. By learning and implementing correct operation, service, and safety procedures, your Husky pump will provide outstanding performance. If you have any questions about how to maximize that performance, please contact Flow's Technical Service Department.